Okay, with this video, we want to use the vector highlighting tool. So to start, I'm going to open a rolled copper demo data set here. You can follow along with this. I'm going to look at an orientation map. What we're going to see is there's lots of different, there's a lot of deformation within this grain. You can see this in the IPF map. If I was to look at this with the CAM map, you'll see there's lots of kernel average misorientation. But we want to look at this with the vector tool. So basically, I want to draw a line. In this case, I'm going to just draw it within this red grain. And I click on the points, and that gives me two different options here to start with. Show point-to-point disorientations or point-to-origin disorientations. So what that means is, as we go point-to-point along this line, what's the change in orientation across each point? So let's look at just that first. And we can see here as we go point-to-point, you can see it kind of goes the same, and then we see these spikes in disorientation. Sorry, I use both terms very synonymously. Now let's repeat this same kind of line here, but now let's include both of these. And here's what you're able to see is that, the red is the point-to-point distribution we saw earlier, but with the blue we can see from point to origin how the misorientation or disorientation essentially accumulates as we go across the line more to get an idea of how that deformation has occurred in the grain. And we can see that going kind of across here a little bit more. We'll go across the whole data set and see both. So here, the blue shows us when we go across larger boundaries, but the red spikes correspond with those big changes. And then down here we have the intragranular misorientation. So that's one way of using this. It's pretty common to look at this for understanding deformation within grains and across grains. Another interesting one, though, is let's look at this data set here, which is the shot peen surface. So I'm going to close all these, and I'm going to create an orientation map here first so we can see the structure. So this is an additively manufactured material. We see there's different grain structures through here. What I'm interested in is the CAM map. So here, what I want to look at, just going from here from the edge, is I can click from one to the other and kind of going across there into the shot peen surface. And here I want to look at not only the point-to-point disorientations and point-to-origin, I also want to look at the map. I want to look at the kernel average misorientation, basically so we can see this as a function of distance. Now, that looks a little confusing, so maybe I want to come in here and edit this and say, let's only look at one at a time. So there's my point to origin, and if we look across that, you can kind of see here we have higher kernel average misorientation. We hit this blue, it's lower kernel average misorientation. Spikes again, hits another blue zone, and spikes again. So we can use this to not only look at the disorientation specifically, we can look at different map values. And another way of showing how this is useful, I'm going to open a third data set, which is this interconnect for chi-scan. And this one's just going to be interesting because I can show the structure kind of going through here. But this one, what I want to be interested in is let's look at the EDS across this. So we look at our EDS maps. You can see we have copper, we have nickel. And so I can create a map just saying, show me going across here with my vector. Show me from here what my EDS values are going across that. So you can see the EDS steps pretty strongly as a step function using that. So when we do this and we create that, now I could do the same thing here, but instead of having this, I could put like what's the image quality through here, and then do the same thing is to say how does my image quality change going across that as well. And you can see we see a dip in image quality at different grain boundary junctions and can try to correlate that with the EDS if we wanted. So that should give you an idea how this vector tool can be used to select different things. I will also mention one thing you can do with the vector tool is here you're able to adjust the width of this. So going back to, let's go back to our CAM map here on this. If I wanted to get a little bit more statistics through this, I could say let's do maybe 12 pixels wide, and then as I draw this, it should go to color here. It should help smooth that out a little bit to get rid of local variations using that smoothing.